Hello, hello, hello. I am here to take on Quest 16 of Everybody Codes. Got my template all ready to go. Quokka running. And here goes nothing. Okay, symbols. We got some symbols, folks. Okay, numbers and then symbols. The 100th sequence is this. Okay. Some kind of pattern, permutation. Okay, so const, first, last. Let's split this up. Notes split on this blank new line. Numbers first split on the comma. And then map over to the numbers. Then we got these lines here. Positions, each wheel turns with a single pull of the right lever. The rest of the input represents the sequence of symbols on each wheel as vertical strips. The machine starts by displaying the first trio. After the first wheel turns by a 1, second by 2, and third by 3. Okay. The wheels turn the same way, resulting in that. Okay, I see. Well, actually, I don't. After the second pull, we should. Wait, where's this one at? Oh, okay, I'm seeing. These are the markings on wheel 1, wheel 2, and wheel 3. So I have to iterate. So initially, it is these 3. But then by 1, I'll have this, and this. So let me see. After this, and this. Okay, I did get it correct, which is a coin for stuff. Okay, yeah, I can just run that. That's circular array, modulo wrapping. Got it. So numbers. This is an interesting one because we got to parse out the faces. Const wheels. Then we're going to make this an array of wheels. And then the number of wheels is actually, something like array, new array. Nah, it's something like from length numbers.length. We want that many wheels. And then I think the second one is the one where I can provide it an array of strings, right? And then we have wheels. There we go, we have 3 empty arrays. And as we go through them, if we find a face in that position, which we'll do some indexing math to get there, we'll add it to that thing. Okay, so for const line of last. And then we just need to get 3 space 3, so for let f equals 0, f less than line dot length. I guess it's okay. We know there are 3, right? So we know the positions are going to be 0. Well, I can split on a space. Nope, let's just do that. Faces equals line dot split on a space. I hope I can. Yeah, these all have symbols between them. There we go. For const f face of faces entries, it will be wheels f dot push face, and then wheels, not webkit URL, should look like. It's a little wrong. 0, 1, 2 push face. What's face? That's not wrong. Faces. Hey, that's wrong. Oh, here we go. Just split on the new line because that's there we go. It's looking a little bit better. Cannot read 0. Okay, well we have 3. 0, 1, 2. 0. That's completely valid. Wheels wheel 0 should be valid. Oh, great. I just killed it. Wheels, yep, that's valid. Oh, not F. Yeah, that's valid. Can I read undefined regarding push? What? Weird. Oh, let's focus on this one because I'm running every other one that's failing on me. Okay, I'm just going to assume this is working. Ah, why not? Sure, let's get in there. I have not the pleasure of using this yet. Wheels F. Cannot read undefined reading push. What the heck? That seems valid. Let me do some classic. And yeah, let's stop the debugging. I don't need to see that no more. Ah, and then we hit undefined. Oh, hey, look, there's another space out there. How dare you? How dare you not show that to me in the log? I guess someone needs a trim. Everyone needs a trim. Notes. Is it down here? Did I not trim down here? Nope. Alright, because when we split by this. Ooh, right. Okay, it was me all along. Oh no. Okay, so I do need to do the math thing. There we go. Const face indexes equals wheels map. Let's drop that I. It's gonna be I times 3 plus I. 0, 4. So let me see. 0, 3, 4, 5, 6, 7, 8. Seems about right. There we go. So for let f equals 0. Well, const f of face indexes will be wheels f. Well, I'll need the entries. Entries wheels w dot push line dot slice f plus 3. There we go. That looks good to me. We just need to get rid of the empties. So what we'll do is we'll say, hey, const face dot trim if face, then you push. Otherwise, you ain't got no more faces. So first one's 3, second one's 5, last one's 4. 3, 5, 4, and we got it. Okay, now time for the rolling bit. So how many sequences? Okay, there we go. For let s equals 0, s less than 100, s plus plus. So let wheels indexes equals 0, 0. Well, it'll be wheels.map. There we go. Yeah, wheel indexes is good. So what we need to do is the 0th pull doesn't count. So I guess we do it at the end, right? So, and what are our results? So let's just say what results is an array. Results dot push wheel indexes dot map wi. Well, this is the wheel, so this will be wheels wi. And I think I'll go ahead and let it just roll over. Somewhere I gotta do the modulo. I'll do it here. Divide by wheels w dot length, or modulo order. Good. Okay, now we do that. Then we say wheel. This would kind of be a let, honestly. So wheel indexes equals wheel indexes dot map w I w, and that'll be wi plus numbers w. Boom, you went forward. You did it. Now we have results, which are a bunch of cool faces. We love them. That one is the one we wanted to see. Okay, and now we're going to turn results into coins. Let coins equals results.map. And then what is result? It's an array. Beautiful array. Array of strings. What are we doing here? For every trio of identical symbols, any additional symbol matching the trio. Okay, I need to look at the example. Starts by showing the first trio, which you don't win any for, so you don't actually push that result, you push it for the after. Okay, 1 byte coin for the triple. 1 byte coin for the triple. Okay. For the extra fourth symbol. Okay, so it's anything greater than 3. Boom, you won. Okay, so I just need to do a counting thing. Cost counts above GTE3 equals cars string counts. Probably put that in there for cost cars. There we go. Counts car equals counts car or 0 plus 1. We are counting characters. Very revolutionary. No one's ever done this before. Return object.entries counts. Only want the ones count where the count greater than or equal to 3. And then I guess I want that back. I don't really care about the format, to be honest, but we have this. We have counts greater than or equal to 3. 1 coin for the trio and 4 coins for the 6. Hold on. 1, 2, 3, 4, 5, 6. What? Okay. Like 1 coin for the trio and 4 coins for the 6. You let me understand this. An extra coin for the 4th, 5th, and 6th. 2, 3, 4. Okay, yeah, I was just failing. So I think what I need to do is just add up all the values. So let me just get object.values, count GTE3, and it'll be result.join. And I'll just sum them all up. Coins equals reduce B. Start at 0 for danger. Between unknown and unknown. Be cool, TypeScript. 3. I also don't know what the value is here. I'm gonna hey, that's some low counts. If anything, I'm seeing the ones that aren't GTE3. Did I invert this? Well, now it looks pretty bad too. What have I done here? I'm just gonna go forward with it. It'll test. That's what tests are there for. Map result. Turn coins. Reduce another. Okay, I know this is wrong. Let's to 245 to be faces. Oh, what? I'm supposed to give you the 100th. Oh, I just did part 2. Dagnabbit. I did something I completely wasn't supposed to. It's probably, what is this? I am an idiot. Idiot is I. Yep, believe that one is good. Expected this face right here. Oh, I didn't realize you're getting multi-directional on me. Yeah, okay. Gathering our tournament participants, some muzzles of... Okay, let's go for our next example. Oh, hey. Them numbers got big, and that's going to tell me there's probably some cycle detection going on here. So let's bump that to a 2. Total number of coins. Okay, solve quest 2. Let's focus. I'll go ahead and copy this. I might be able to brood it. We'd never know. Total number of coins won so far. So first, I guess I gotta get the coins working for simpler examples. So let's start passing a second parameter for what round we get to. Well, for pull 10, we're expecting 15. I'm going to do another one for pull this many. I can clearly see the repetition in the numbers though. Okay, and that was great. So solve quest 2. Polls number. We're just gonna, go for it. Polls, right? And then I get to actually do my code with the coins. That's totally not broken. What do you mean this thing wasn't working? Okay, let's wrapping. Yeah, expected 21 to be 15. It ain't doing its job. So 1, 2, 4, 5, 7. Let's look at the coins. 3, 3, 2, 3. Yeah, everything's wrong. Let's look at the result. This is the same one, I think. 3, 5, 2. Or 3, 5, 4. Okay, it is the same. So coins is supposed to be 1, 1, 2, 1, 2. Yeah, a bunch of other different numbers that aren't what I have here. Okay, result. Let's get all of them, please. So, right, flat, up. Should give me a 1 byte coin. Okay, so let's see what we got here. 2, and then we have 1. So we have 2 ups and 1 flat face. That's not inaccurate. Where'd the rest of them go? Okay, put that join on here. Maybe that does something. I don't think it does. Yeah, we're just counting characters here. This should not be the craziest thing I've ever seen. Car of cars. One to the right, 2 dots, 3 hyphens. Yeah, we have this. I'm doing something wrong. Yeah, I should only be keeping the hyphens. Correct? for the triple, well, not after this one. 1 byte code for the triple hyphens. Okay, so let's see what that looks like. Ah, they've done index, not count. It was me. It was I. The idiot was I all along. Okay, this is all gonna work pretty good now, I imagine. It's down here, of course. Ooh, still not working pretty good. Okay. Ah, well, once it's 3, you basically flatten it. So, so I think it's -3 on the B. Come on, TypeScript, just be chill like that. Okay, maybe not -3. -2 is what I meant. 1 1 2. Okay, I think 1 1 2 1 2 1 2 1 2, and then it's gonna go and do its thing. Yeah, like that. Okay. Don't see what's wrong here. Look at 17 to be 15. Am I just off by 1? Wait a minute. 1 2 4 5 7 total coins. Okay, so that's not the exact thing I was counting. Okay, this is annoying me. Just be chill, TypeScript. Thank you. Whew, okay. That one's not liking it. Is this one liking it? No. Throw a flat number. Am I literally just off by 1? Because if that's the case, I can... Boop. No. If anything, I was off in the other way. Which, okay, is doing better. Expected 15,498. That's concerning. That means something went wrong earlier. 100 to 138. Wrong way. Aha. I am doing something wrong here. Because that should be 138. And then, yeah, that causes everything else to be wrong. Yikes. Bad. Maybe I should go read the rules. Calculate the coins 1 so far. What? The muzzles of cats are ignored. Only the eyes are interpreted. So you know where the middle button tarnation rules is this. Okay. So I need to do this, but before I do that, I get rid of the middle characters. Let's map face. I guess we're returning face. This is what I do now. 14 to be 15. Well, I got rid of the muzzles. Only the eyes are interpreted. Do we define the muzzle as the middle character? Okay, here we go. Left eye, muzzle, and right eye. Okay, so I got things going better. And probably if I put my indexes back, this might do its thing now. So I think I just got a little lucky. Oh, hey. I need to patch this to the really big number that's going to kill Quokka. We'll find out because my fan will start going really fast. My fan has started going really fast. But honestly, that doesn't seem too treacherous. I will need to do cycle protection on this eventually and fast forward and all that fun stuff. Let me see. Yeah, do I need to do it for the real one? I might get lucky. Let's see. What are we on? 16. There we go. Oh, right. I forgot the... Yeah, go away. Let me do my thing. Okay, so it's going. Fan spinning up a little bit again. Cycle detection. Yay! So, this is a good thing that I chose to keep the results and not the coins, because I'll need that to detect the cycles. Ooh, yikes. Though, if I didn't do that, I probably would be able to be a little more efficient. So let's just say let tool equals 0. Drop the results. Let the indexes go. Drop this total plus equal. So we have our result. Let's do the necessary mapping and then the joining. And the joining, then once you have all of that, it's everything before it and everything after it. The most readable line of JavaScript you've ever seen in your life. I'm joking. Okay, hey, what's the worst that could happen? It could be wrong. I'm wasting my time running this. I'm gonna line comment and then start smart, because I should be able to at least get these. Alright, I got rid of all those bits. I can focus on this one. Describe is not defined. I just put it back. Right, so it's there. It's all happy. I put it in the big one. Well, it's hard to tell while I'm still running. Okay, it's that big of one. Stop. Let's see how terminal's doing. Okay, yeah, it's not brute forceable. We will need to do that cycle detection. So let's put the results back. Get the total out of here. And good old cycle detection. So I think, well, simply seeing, let me see if these are unique. They appear to be unique. Let me go grab the input. Oh Lord. Okay, there are backtick characters in here. I hate that. I absolutely hate that. Okay, how do I do that? What is it? String.raw? It's not doing it. I need to pull this in a file really quickly. It says I can do that. Oh no. Okay, yeah, so let's just two text. There we go. Has zero impact on solving this because I still need to actually get everything else working, but I believe I'm seeing enough variance here. I don't think I'm gonna see it. I think cycle detection will work with my naive approach. So I'm gonna go with my naive approach. It's basically the last index we've seen this result at. So in order to do that, I need to push the results themselves in, not as a string, so that way I can do an index of. Otherwise, I'm going to do a find index, which, since I'm doing cycle detection, well, should be enough efficiencies. So basically, const result equals this. If not result, find index const index equals r JSON stringify on equals JSON stringify result. Sure. And you know what? I don't even need these. I could just use the wheel indexes, because if they're ever pointing to the same thing, that's a true cycle. But I've already written the code like this, so we're doomed already. So if cycle index equals -1, there's no cycle. Just keep going. Otherwise, there's a cycle. And I think what we're going to do is we'll use this to increment the s. So let next s equals s plus, so const increment equals s minus cycle index, or is it length? It's some degree of this. It's going to be fun, the off by ones, but we'll do this. So s equals increment while next s. So if cycle index is -1, we also need to do some stuff here of, I think I'll just put another embedded for loop to do this for me. So while next s less than polls are still legal, then it will be, I'm just gonna, I think the way I did it before was building the array, and that was ugly. Let's just keep building the array. We will max out our heap quicker, which will let us know we're doing it correctly. So that will be results dot push results slice cycle index. Yeah, I think you just go to the end of the array there, buddy, because you just literally found it. So you push all the ones from the old one, right? And then what do we do? Next s plus equal increment, right? And then eventually we're going to hit there, and then it's just going to be for this loop, or while this loop rather. Yeah, so did I paste both of that? Weird. While s less than polls, just do the manual, do the rest yourself, little buddy. You're gonna manually move your way. Well, technically we can use math to indent you to do the other bits, like figure out the partial and do that much of a slice. Const remaining equals polls minus s results dot push slice cycle index and then what is it? It's, well, hold on, if I keep pushing this slice it's gonna go to the end. Cycle index index plus s, right? We have to make an end, and that end is where we're currently at. So it's cycle index plus s minus remaining, which I'm going to leave that typo. And that should terminate this entire party. I'm writing a lot of code here. None of it probably works. I'm curious. Well, I think we'll hit a cycle within the first these ones, so yeah, I think my terminal's still running on that thing. Let's let that one have its fun. So let's say crank quokka back up here. I can put one here too. So smart start. Let's go. Boom. Expected 0 to be 15. Oh, whoops. A daisy. Oh yeah, we're not doing the rest of that. Hey, let's put the math back. Okay, good. Let's get rid of the first one. Our first cycle's doing stuff. Okay, a little dangerous. Okay, it's either gonna work or it won't. So there's a possibility we never found a cycle. I don't really consider that. I'm considering it now. Let's drop this one. And let's look at just this one. No, not CSS style detection. Cycle index. All the cycle indexes, please. Okay, I'm literally running it on one. What are you choking up about? Okay, I do have this process in my terminal eating me alive. Let's kill it. Wallaby. There we go. -1s for all eternity. You never found the dumb cycle. I think there's a cycle on there, Wallaby. I mean, it's not Wallaby, it's my code at this point. Results. Oh, we're never pushing. No, we are. Results push result, yeah. Oh, look, I need to see all of them. Thank you. I believe my whole thing depends on cycles. If we never actually hit a cycle, okay, I can just do some simple deduping then. Results map l dot join, or so you in a new set. Come on, I didn't break it. Okay, first I need to refocus on that one I care about. There we go, help a little bit. Hey. What is going on? Why? Is this wrong? I can get rid of these. Okay, I have results. I have cycle index. Let's drop that. Let's just look at results. There, they are there. And finally, 100. Boy, you just didn't want to work for me. 36. There are duplicates in here. You have to find one. Oh, did I say result? It was meant to be results. I'm a goof. Now I bet you got some cycle indexes. Are you working? Ooh, new invalid array length. Okay. I could be going past the end, which, sure, I'll take it. Invalid array length. That's a fun one. Let's check out our cycle index, our favorite thing to look at. Five to 2. We found a cycle at 5, then we found a cycle at 2. This is not the pattern. Okay, so I guess assumption of this input. Okay. Yeah, this is not the cycle detection I was looking for. I need a subsequence or a sub results list that is seen multiple times in its totality, not I've seen this one literally once before. Okay. Yeah, that's what that means. Okay, let me think on that. It'll be expensive. So, I'm trying to think what we can do here. Thankfully, we have it approaching or us hitting our cycle within 100. I mean, 100 is a lot, but it's not that many. So if we just results, right? I mean, it's a lot. It's not a lot. It's been a while since I've done cycle detection. We think cycle detection. No. Yes, I have to detect a cycle. No, not like that. It's not circular though. I mean, I could make this into a circle. Okay, let me look at these cycle indexes. Cycle index and S, so it's the new index. We see both of them. Okay, if it's one. Then we care to see these logs. Okay, so 5 and 14. So we have up, flat, in, up, flat, in. Okay, so I see that and I see that. So the next one is flat, then the comma one. So I'm expecting to see 6 as flat and the comma one. No. So I think me using the results is wrong. I need to use the indexes. I mentioned it and I was like, these are fine. I don't need anything else. I think I was wrong. JSON stringify wheel indexes to R, which is wheel indexes. There we go, and boom, these are my real cycle indexes. They never get logged. Well, I never push anything to them, do I? No, I don't. Index results, push wheel indexes, which since it gets mapped, it's good. Okay, still never hitting it. Interesting. I'm logging the R, which is the index results, to the current wheel indexes. This is what I expect. I'm not moduloing over the things because I do the modulo in here. Let's put the modulo in here now. So yeah, we do the math. We do modulo wheel over that one. Hey, look, we have some cycles. No, we don't. We're saying everyone's a cycle. This is looking better, though. This is looking much more like a cycle because it's incremental. I'm not fast forwarding. I like it. I think we found it. So we just have to use it off of wheel indexes, not results. Well, though we could use wheel indexes to push the results. Be a weird gross double, but let's just try and get it working. So before I hit this thing and make it go crazy, increment S, yes, all of that goes correct. These minus ones might not need to be here. Let's find out. Yeah, I don't think we need to push the wheel indexes. They were just to detect it. I have detected it. Yeah, it's broken. That's understanding. There's a lot of stuff could be wrong here. That's a big number. Yeah, I don't doubt you. So increment 60 next S. Well, how many poles are we going for? 100. Oh, yeah, we just overshoot it. That's cool. That's cool. That's cool. Well, that's false. So what is remaining? 40. Okay, so I mean we're going from cycle index to cycle index end. Cos E equals this E 19. So we're going from no, not that 0 to 19. Feels a little weird. Hey. Okay, I was about to be really confused about that double log, but no, that's doing its thing. So yeah, our increment was 60, so we're having a cycle of 60 long. That makes sense. We can't go the full 60. We're very sad about that. Which means we get to only go the 40, right? So we go from where we are, which is 60, we add 40, right? So this is going from 0 to 16. No. Okay, so I think this is our old thing. Let E. So let's just start with what E would normally be. E minus equal. Well, plus equal minus remaining. Whatever. Let's look at the E there. Yeah, 59. This is supposed to be to the end, so I'm not liking that -1. Hey, maybe we use the variable we're playing around with. Crazy idea. So slice from 0 to 20. I need to add 40. Can I just add remain? This seems like what I want, actually. Drop that one. Okay, it's not working, though. Expected big number to be not that big of a number. Hey. Why are you going so big? Oh, am I not modifying S? Oh, that's on me. Oops. S equals poles -1. Then it'll be, nope, S equals next S. And here it'll technically be S plus equals remaining. Okay, why has fans gone up? Why fans? Oh, it's working. Okay. scared of fans being fanny, though. This is supposed to be fast process. Am I doing too many logs? I can trim those up. Nope, not that one. Trim. We are building a lot of unnecessary memory here, I will admit. Once we do also detect that cycle and start trashing information, I'm gonna put that return back because my computer is now eating itself alive. 1388, right? Okay, let me reduce the impact here. So once we have this, we kind of don't need it. Once we do results, we also don't need results. We just need the total. Well, we need the coin amounts up to that point to do the math. So let coins. So this bit, gross, is what we're doing. Result, yeah, we don't need you. You're not cool anymore. Yeah, you're not cool either. Yeah, it's nice to know you're there. Right, so just continue as normal. Don't worry about it. And then, yeah, I guess that variable does end up in here. Oh, it's not results map, it's result. Boop, boop. Ba-da, ba-da. There we go. We do get to use this variable. That's not a thing. It's just pushing a freaking function. No, just push math, please. There we go. We ignore the facey or whatever. Boom. We do that only in here because that's the only place we need it. Because down here, we push the coins with the exact same stuff over here. So much to the point that I'm just going to go copy this and just call it coins. Well, I'm going to misspell coins first. Okay, I think that will be good. 1338. I think it died. No? Okay. Let's get this one back alive, I guess. Hey, we broke it. That's great. Oh, we're not actually returning them. We move that up to there. Great. It's all broken. Well, this is supposed to be working, especially for this simple cycleless. Coins push. I mean, it's a thing. What the heck are those tab characters doing in there? Oh no. This is bad. What am I looking at? What happened? So you're doing the modules up there. That's perfectly fine. Wheel indexes. What am I looking at? 1, 2, 3. Wheels? Did I just goof the parsing? Oh, I did. That was me. Okay, now it's it. Dang, where are these? What's going on here? Oh no. I'm an idiot. Okay, it's working. Let's drop some of our logs we just threw in there. It's still working. Let's go to the next level. Dang it, infinite loop. Okay, we need to get in there. So yeah, next does polls. We're doing this one, so we're forwarding by this one. We're detecting a small cycle, right? So this one can be mathematically done. Let's figure out how many we can do here. And we're doing a bunch of pushes to an array. It's gross. We don't want to do that. As soon as we get to this point, we just want to be chucking totals on it, honestly. So total is right here. And I guess 2TL plus equal coins at -1. And then, yeah, we don't want to push these. We just want to get const 2TL of range, which is slicing there we go, total of range, and then we can add that straight to total instead of doing the array manipulation. It saves a little bit there. Now we don't return coins. That's a little better. We have to do the exact same thing here. Thankfully it's a one-off. Feeling better about that. Still doing this a lot of times, but it's pure math now. Okay, I'm liking it. I'm liking it. I'm liking it. It's the bigger number. I think this might be to the point where we can give this a direct run. Let's go for it. I think my terminal's still over here waning. Yes, it is. Okay, before I give it the real one. What? Describe is not... Okay, it ran. That's a number. I'ma put it in. Ooh, everything about that is wrong. Jeez. Okay. Interesting. If I put in this number, do I get my 138 with 3 3s? No. Oh, did I goof with the paste? Hey, I think it was me again. Hey, look, it's... I love it. So, but it did computationally run. So once I do this and I wait another 10 seconds, I can't remember how long it was, it'll work. I'll run it with the real one. I'll have a real number, which I shouldn't even be trying to submit anyway. I'm going for an assertion. So 288134. Okay, I think I got it, which means I can run it against the real one, which I'll need to, nope, not request animation frame. I need to get it from the file. No autocomplete, because who needs that, am I right? So I think I'll just chuck this into here. Alright, what's the worst that could happen? Can't read undefined of split. I could check a trim on there. .ts. It is in there. I'll look at the thing for you. What is not construct trivia? That's gonna be a big string, gonna blow up my terminal. It doesn't look wrong, I'm just splitting by the double new line. Last, cannot read properties of undefined regarding split. The heck is last? Last is the thing on the other side of the thing. Why? This is parsing junk now. Oh, it's a backslash issue. Well, thanks, Windows. I don't want to console this. You know what, Sean? It's going to be a singular log. Look, if split properly. Oh, this split, it's going to hurt. Do I have trims on things? Where do I need the trim for last split? Line slice. Okay, I got the trim, so that should get rid of this little fun bit here. Now, this is more, so I could expect this cycle to be longer. I'm a little worried though. I would have so it could be longer till I hit a cycle. That's the thing. The longer it takes me to hit a cycle, the more index results I'm just going to be adding and adding and adding and adding. More coins I'll be adding too. Okay, I need to think of how to target down that, because it's chugging, obviously. I mean, this isn't the prettiest thing. I could do some inline math here and make that better. I mean, it's a 3-thing comparison. Yeah, I can make it better. Let me just keep this line for reference. So let me see. R dot every vi v equals wheel indexes I. Sure, my value equals your value. We're all happy. So that's gonna keep chugging along. Yeah, I do this great, amazing transformation, which could be simplified a bit. Not by that much, honestly. I mean, there are transformations here that I'm just wasting all of my memory in the universe. Yeah, let's go for that optimization, and then spin up another instance without a dead terminal. Yeah, basically we just want to do this not grossly. Okay, so characters we're considering, we do the same, we do the counting, we just only look at the ones that have reached above the thing. Count equals here. Car of, same string for car of this. Counts car equals counts car, or 0 plus 1. Then we can do if conditional here. If greater than or equal to 3, which is more parentheses, honestly. All the parentheses, can't have too many parentheses. Watch another parenthesis. There we go. So yeah, if you've done the thing, then we're going to say, hey, congrats. So let counting. Actually, we can just start adding points, right? Let's see, coins equals 0. C coins, boom, just keep adding them, and then is C coins. C coins. Yeah, that's how that works. I like that. Means we can drop this. We do have to still push it to the thing. Yeah, I think I'll let the terminal go a little longer. But we're bringing this back down to reality, unfortunately. Drop this. I think I still have it down here. I do. Let's return, for Wallaby's sake, smart start. Let's see if we make it good. No, cannot read undefined reading split. Who's doing that? Oh yeah, the weird thing. Thanks, Windows. Big fan. Drop that, drop that. Oh, wow, it's green. That's cool. Okay, big fan of the green. I didn't need to put a thing on there. It's just gonna run. Now fan is going double fast. Yeah, let's kill that old job. Right, I forget this one's the big one still, despite said optimizations. Okay, let's log it, and don't forget to reduce my indentation. Get rid of them darn tabs. We did that. Let's drop that. And bring the terminal on back. Boom. Okay, it runs, I guess, in an okay amount of time. We're still not being fast, though. I can feel it. So we just use index results to keep the last time we've seen it. This can be a hash map for sure, where it's just the JSON stringification either way. So we go for that next improvement. Bring these back. Yep, those are all still there. Let's drop these. I'm not even gonna run up the real one. I don't believe I have the efficiency I need. Coin slice, coin slice. Theoretically, my cycle includes the beginning, so I can just keep totals and not keep the total amount of coins. But let's go for this one first. There we go. Index results. Index results. JSON stringify. Let's just do the easier one, which is just wheel indexes join equals s. Right? That's the index. There should be. Let's keep this one around. I'm about to go crazy with this. Equals index results will indexes dot join. So this is really a key. Might as well keep this around. Key is boom, boop, 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 key. I mean, no matter what we do, we're gonna put it in, but let's go for the easy one where we were doing it before. Do that, do that. Okay, let's make sure this is still working. Let's move this around up there. Okay, still working. Wake back up. Ah, okay, was broken. That's suspicious. Okay, so we have our key. We say, hey, are you in there? If it's not equal undefined. If cycle index equal undefined, not -1. Boom. Okay, how we doing there? Progress. Okay. Enough to hit that? No. So we still have this coins array. That's currently my #1. We gotta keep wheel indexes alive. That's a thing of size 3. We could not redo the assignment thing. I don't think that's the end of the world. Actually, let's go for it. Let's go for the terminal. Well, that's a weird comment. I should be really fast here. It's not the speed I was looking for. I was also looking for it to actually solve and be the right number. I was looking for so many things. This goofed. How did you do that? Must have been when I toggled the comments. It messed up my white space. Okay, it's there. It's a little faster, I'll admit. Let's hit it. And I will think of better thoughts in the meantime. Gotta forget to, well, I have to not forget to do
my return carriages, because Windows is great. So, oh. It's either working or that's a number. That's a number, okay. Add a second lever? How dare you? You may pull the lever on the left side to move all wheels downward by one step, or push in to move. What? Oh. Before pulling the right lever. Oh. Wait. When can I pull the right lever? Or the fancy lever? Hold on. Let me see. When can I do this thing? Before pulling the right lever, you may pull or push the left one. Is this at the beginning? Only once or not at all. Before pull. Okay, so it's basically 3. We just tripled our things. So with the pull the right lever, the result may be, yeah, we move things. With a single, the maximum you can win is 4, and the minimum is 1, so the answer is 41. What? Okay, I see it somewhere in here. I don't fully see it now, but it seems very achievable. Let's do it. I don't need more comments. I needed less. Yeah. Do I have any? Yeah, my notes for that are in the thing above. I'm not putting Clocka back on that. That's gonna kill me. But example 3, I got something right here. Let's do it. Our fan favorite. So for 256 pulls, man, what do I return? Answer will be 4-1. Oh, I returned the min and the max. Cool, big fan. Okay, this doesn't sound bad. This just sounds like run it 3 times, give me min and give me max. I feel like I'm really missing something here because it cannot be that straightforward. Let's get solve quest 3 in here. Solve quest 3. I bet I won't be able to paste this in. Oh, look, they don't put illegal. I mean, not illegal. They don't put backticks in there. Ain't that nice of them. Let's focus on our problem. Yeah, let's get part 3 in here. I don't even think, honestly, like all this weird fast forwarding stuff, I think this is going to be more of a hindrance than anything. I really do feel like I'm missing something, though. When all wheels have stopped, you may pull the lever on the left side to move all wheels downward, or push it to move all wheels upward. You don't win. You can only do it once and not at all before pulling the right lever, which triggers the spin. Calculate the maximum and minimum number that can be won with 256 pulls of the right lever. I feel like I've missed it because it feels like it's saying my first interpretation was correct, where, hey, at any point you can pull that left lever. It's like infinite branching trees craziness. But my second interpretation was that you get to pull at the beginning or the end of the entire session. Before pulling the right lever, you may push or pull the left one. So, lore-wise, pull the right lever, reveal a new sequence of cats. Yes, you can do it at every point. Okay. Ooh, boy. Yeah, I'm not seeing no more simplicity here. Because Wait, is it just moving one or moving by your thing? So before pulling, you may push to go down to flat face, right face, end face. Oh, starts with the first trio, right? You may push, okay, pull. Pull goes forward, jeez. To go there, there, there. Yeah, that literally changes everything. It's a whole new cycle, a whole new universe. So if the first pull, you have those three universes. Okay, is it the time at which you pull? It's maximum 4, minimum 1. 4, 1. I'm also confused a little bit with 1, 2, 4. That's 3. With a single right lever pull, the maximum number you can win is 4. The minimum number is 1. That's not a single pull. That is 3 pulls. You did it 3 times. You went through the entire left wheel. Does a single pull go through the entire smallest wheel? That's not right. Yeah, pull number 2 gives us this. Words. When all wheels have stopped. The heck does that mean? You can only do it once or not at all before pulling the right lever. I'm just trying to walk through their example here. For 1 pull, it's 4, 1. Okay, so I just go minimum, maximum. Why is there only 1 here? Okay, I have 3 of those. I also have 3 of those, but I don't count the noses. 2 of those, so I have 4 of those. 4 of those. I have 1, 2, 3, 4, 5, 6. So 3, 4, 5. Yeah. I don't really get it. I'm gonna start writing some code. Thankfully, I think cycle detection just died on us. So RIP cycle detection. It's a nice one that you lasted. Not really. I hated it. Yeah, so we're doing the thing. Well, I mean, I can at least write a couple tests, thankfully. Alright, how many pulls? Hey, I don't know. Guess as good as mine. So we'll go 1 pull, and that should give me 4, 1. So let me write the big test, which is 256. That one, just write a few others. 1, 2, 10. 10 is 26.5. What do we got for 2? 6, 1. For 1. 4, 1. Sure thing, buddy. If we have pulls, for this, we're going to do through it. And we're just going to keep track of the min and the max. So what does it return? This is really the baddest way of doing it, but I need to try something. So yeah, that's not gonna work off the top. But let's get something going here. Yeah, expected 1 to be 4-1. Very cool. Great, we're doing the only one to be 4-1. Did I just put min and max on both? I didn't. Okay, what coins do we got? 1 coin. Hey! Yeah, so this is the fun part. With a single right lever pull, yeah. I'm seeing 3 things here. Okay, I gotta reread this again. When all wheels have stopped. With the first pull of the right lever, the result may be why is the result may be this? I see it's the 3 here. Yeah, you have flat, right, and then left. Well, you're in middle, right? So it's 1 would take you 1, 2, and then 2 would take you 1, 2, 3, 4, and 3 would take you 1, 2, 3, 1, 2, 3. So I see how this is being generated, this left one. Same for the right one. But why 3? The result might be a single right lever pull. I don't see it. If I look at the input, maybe I'll spot a similar pattern. I mean, no. You know what? I might not be. I mean, I could just keep staring and try and reread this, but I am not comprehending the problem itself. Because we all know you can't just write code for a problem you don't understand. You have to understand it before you can replicate it. All wheels have stopped. Yeah. I do not see it. With that, I will be taking a break. Returned I have. And I think I'm ready to take on part 3 here. So, our last left off, it was basically, I'm not seeing the logic here, was basically the TLDR. And I think it's just kind of showing what's going on, which isn't really too helpful. But I don't think this example is exactly what's meant to be replicative. But what I mean by that is that it's just showing, like I think I should just try it out and see what happens. Is basically what I'm saying. This example, I got a little too hung up on it last, so That's what I will do. Let's focus on this one, which is already running. I think it's really just try all the variations, unfortunately. Right, so we have this. I think the trick I need to do is it'll be at every position, every poll, which is an individual poll. You can go previous, keep current, or go next. And those is basically what you can do at every point. So, I think I'm going to do my favorite kind of recursion, which is stack-based. Const remaining right here, lovely array, and then it's just going to be while remaining dot length thing equals remaining dot pop, and we're just going to go through all these. Now, what are these? I think it's going to be my initial positions of the wheels. So that would be wheel indexes, which in this case is a bunch of zeros. Where do I have that? Here we go. Boop. So yeah, we start with wheel indexes, a bunch of zeros. We next then go with basically our current poll, which I guess we'll call P, so it'll be 0, right? Yeah, we'll call it 0. And then our next one, this is the trick because we're looking for both. I'm trying to think, can I look for both at the same time? By both, I mean minimum and maximum. Let me think. Oh, Wally's going crazy now, don't you? Let's stop. Probably should have restarted VS Code when I got back, honestly. Trying to think. Maybe I can just go for both. Let's try going for both. And the reason I need to build this up is because this is, when I build a cache, what's going to go inside of it. I'm trying to think. So the end result of this, again, if they're thinking it through, at some point I'll need to keep track of the last one, which I guess I'll just have two little variables to do. Okay, I think that's what I'm ready to go for, so let's destructure these. Wheel indexes and poll. Now that we have this, we need to make a key for our calculation and memoization. Wheel indexes, poll. Let's use my favorite character right there. We don't have TypeScript, that's okay. Boom, there we go. TypeScript is happy. Cache is right here. If not key and cache. Well, it'll be if key and cache actually. Return cache key. Which I won't really need to return it, really. I'll just need to stop going. So it'll be, give up, fool.
I'm trying to find the termination case here. I'm not really seeing it. I think once I run this, I'll be able to console log the cache or something and find my end condition. Okay, but at this point, yeah, you don't have it. So I'm trying to think of any case. Yeah, I think this is enough. We just now need to get previous, or get, what they call this one. Get forward, get backward, get current. So const coins equal. I think I've just been doing this inline, right? Sure, yeah, let's just do this. Make a tiny function here. What do you need? You need result, which is an array of strings, like so. And I return that. Boom, we love it. That is count coins. We need to pass you a result. So we were doing that previously by mapping those to those. Yes. I think we do better here. Yes, it could be a more direct way, no middle logic, but we're good there. And then it'll be const next or forward coins, which is before I map the wheel indexes. Basically, I +1 them in modulo. Wheel index +1 modulo wheels dot length. I think the other one is just -1, but it's an under modulo. I'm trying to think. There's another way of going around that. I'm not gonna figure it out. Guess I might as well. Yeah, I was modifying this one to get previous. Let's go ahead and do that up here. Give me a body. Backward coins. There we go. Okay, we have this WI, but our WI needs to go back by 1. So WI minus. If WI equals 0, well, is less than 0. WI is wheels. Nope. Timon dot length -1. There we go. That's the reverse modulo stuff I needed. So we have coins for all 3 of them. Now I'm trying to think. Basically want to, this is the part where we add more, because if we're not at the number of pulls, which is up there, okay, so it's not at number of pulls -1 because we're starting at 0. Let's fix that. Let's start it right there. Okay, so that'll be if pull not equal pulls, then you're just gonna keep going, right? Like, we keep adding more and more and more, and we add them to this one. Okay, so I think the end condition I'll look for is I'll look for the thing in the cache with a key that is the latest pull, or I'm just gonna put an else block in here to save it. So let's do that. Backwards coins plus equal. Oh, we can't add that because we need to wait for the results to be calculated. Oh, this might have been easier as recursion, honestly. Okay, so if I just keep this value, I'll have to push it forward then. Interesting. So I have number,
I do 3 more numbers, basically, that'll hold all of them. Or rather, just say that. And I guess for here, it'll initially start off as 0, 0, 0. Okay, I can do that. So let's destructure it here. Boop. And forward chords. We have our previous ones. And now instead of these being assignments, these are plus equalses. I don't know why you hate that. I destructure it properly. Maybe I typed it wrong. There we go. Okay, so we have this. If you're not at the end, then keep going forward, which is remaining dot push, basically where we're at. But it's all threes, because you could have went either direction. We don't know which one you went. So it's first my wheel indexes, which I need to recalculate, I guess, from up there. Then my pulls, which is pull plus 1. Then my numbers, which is I have right here. Yeah, that's all I have. So now I just need to go back and grab the indexes. So backward indexes. This one's fine. But I need them before this. Turn WI. There we go. Yeah, so I guess all 3 of them are going to have this map on it. And then it's cause indexes. It's basically this logic. Love it. Forward indexes. Yeah, I can definitely see the optimization of removal of the middleman for this bit here, but we're good. Then we have new wheel indexes, which we did not move forward. So let's fix that. Right? I gotta move them forward at some point. Yeah, because forward means I did the thing to go forward. Backward means I did the thing to go backward. And the pulls naturally moves along, so I guess I need to do that up here. Okay, I'm struggling a little bit my ordering. We'll find out. We'll find out. Let's put them in here. For our first universe, we went backward. For our second universe, we went nowhere. For our third universe, we went forward. Right. And then, I think no matter what happens, I'm trying to figure out where the cache goes, because I made it, but I never used it. I think I use it here before I start throwing more things on the stack. Basically, the end. So, I'm going to need a cache from both min and max. I could just use the same cache for both, I think. Yeah, so let's... If it's seen before, doesn't recalculate. Okay, so we have our key already, which is where we currently are in the index of our pool. Does that have enough information? Not honestly seeing I think it does. Let's go for it. So cache key equals, well, I guess it's both of these things joined by a string, right? So it's this. Whoop, come on. Dot join string. So first it's, what is it, min followed by max? Which is these rules. Max min, okay. Math.max. That's what I got right now, so backward coins, forward coins. Followed by the min. Okay. I think that's gonna work. What we're gonna do with these results, that's gonna be a fun one. Because basically all the results are going into key, that going into our cache. I think we need to do something here. I'm just gonna throw a call log in there for now. But we gotta do something here. Let's get Wallaby cranked back up and start seeing this thing run. Oh, okay, so maybe this is it. We just hit the end and boom. We're lucky. We're looking pretty lucky. Four one 4-1. Uh-oh, that's our second thing. It's not doing anything, is it? Where's our? Oh, that's the only. Okay, expected 4-1 to be 6-1. Yeah, we're supposed to go a little bit longer there. Is there more remaining? No, so we actually did run out. My one? It's supposed to be 2 pulls. Expected 4-1 to be 6-1. Hey. No, you're not showing all of them. Okay, there we go. Aha, the other one did have some more to go, so we didn't want to immediately return. So I guess we'll keep the return down there. We want to keep the end terminations and then choose the best of the ends. Okay, so let's say const finishes, which is array of number. Actually, no, it's just an array of strings. It's just the keys. There we go. It's future problems to figure it out. There we go. So that's the one. So I think you just go through them and you find the minimalist and the maximist. Or it's just -1. Return finishes to at -1. Just shove that in the cache. I just hit the freaking numlock. Come on, keys. Something's chugging. Hey, what you doing? That's okay, that's on the wrong one. It's 4-1 to be 6-1. Okay, what are you doing? It's not being nice. Oh, because I have a return here. I thought I just put all that code there to not do that. There we go. Okay, so for this one, it's a chugging, and we're passing both. Okay, so this might be just last one is the right one. Let's see about that. No, 26.8 to be 20, 23.8 to be 26.5.
So maybe we have to go through all of them and be like, hey, you're the lastiest of the lastiest. You're the best of the last. Okay. I think this is only 10 iterations. We can handle. Do we have a finish? That is what we want. So let's just look at all of them. Alright, well, cache K, I guess. Which one we said we're looking for? We're looking for 26.5. We never even made it there. Oh, that's a problem. Not that we didn't pick the right one, it's that we did not get there. Yikes. Yikes. Is that correct? For 10 pulls, 26.5. Yikes. So this is... So at this point we hadn't circled around the first face. Do I have all this correct? It appears to be happy. Yeah, but all of them are 10, so they're all at the end. Yeah, these are just their positions. They don't give me any insight into what's going on. Get to 23, 8, 3, 4, 5, 8, minus 6. Feels like we're just off a little bit. Does that give me a little better? 27, 9. That's not giving me the 26, 5 I want. No. Okay. So I'll put it back to 1. That was correct. Okay, we move all wheels forward by their jump numbers. Then we move them all backward by literally 1. Move them all forward by literally 1. Right, this is what I expected to do. So I am pairing the maxes up with the mins. Do I need a min cache and a max cache? Or the best minimum ever min? Do I have... Basically, I need to see if these two numbers show up individually, just not as part of a pair. 26.5. God, I gotta keep... Nope, gotta stop thinking. Or gotta stop looking that number up. Let's make that easier. 26.5. There we go. That's what I'm looking for. Dang, we never even make it to 26. If we do the off by 1, maybe. Do we make it to 26? No, we don't. So our maximum never hits the maximum we're supposed to hit. Our minimum does, though. We hit that one fairly past, though. I feel like I'm supposed to do something else. It's fortunate it's working for the smaller cases. I believe I have even a smaller case to go. Yeah, 2 and 3. I didn't test the 3. Let's do that. We're supposed to be 9, 2. Let's make sure all of our spaces are correct. Okay, so even this one sucks. This one. Blah, blah, blah.
Is this a larger or a smaller sample size to look at? So we're supposed to be getting, oh geez, what was it? 9.2. So both of them technically are in here. So I'm just going to go for that approach. I guess it's going to be cost min equals finishes dot map k cache k. Yeah, okay, it's just going to be a for loop. Cost k of finishes. That'll be that min equals number max. Wow. Number min safe. I'm just gonna go through this. Const min max equals cache k dot split. Right? K for key. Then it goes math dot min. Same for max. And then we return see if that does it. Ah, come on. Expected 5.4 to be 9.2. Okay, I think I did it literally opposite way. Let me fix that. That one's on me. Huh. Nine two. That's what I expect. If we went on to the next one and we're failing, is that what's up? Expected 2.9 to be 9.2. Dang it, I did it again. Okay, so we're on that one. Let's hit up the next one. Our problem. 2370 to be 26.5. I still have that one index change I in there? I do not. And we never hit. What is the one we're looking for? 26.5. We never hit 26, and we never hit a low as 5. Huh. Feels like we're just not running through enough. Or I think my coin calculation is right. I mean, it's been right this entire time. Wait a minute. Do I look at the muzzles or not? It's working on the example, so I think I don't look at the muzzles. There we go. Yep. Okay. Let me see. So if it doesn't equal, we keep pushing forward. Eventually it will equal. The thing is, we never look at it at any point in the middle. We only look at it at the end, which I think is right. Do we want to also look at it in the middle? I don't think that's going to give us what we want, but hey, let's go to stop it. Let's just go for it, right? 9 and 1. Yeah, that's what I figured. You never reach the end, so we never know. You need to reach the end before you're a valid, like, full play of the game. Okay, so we have backward indexes, normal, forward. We all move forward through the thing, keep our coins. Feels like this should be working. Wait a minute. Nope, that's right. Because we're kind of building it forward. You know what? Let's see. I don't know if this key cache is even doing anything. Wallaby has died. Because right now we're on relatively small inputs, so let's just hit them all. 24/7 to be 26/5. Did I ever get 26/5? Okay, so we get a lot of repetition. Okay, let's try and make this unique. Or is finish is not unique, or is there cache results? Someone's making a lot of noise. Boy, you making a lot of noise. Okay, I'm seeing its duplication in here. Yeah, so a cache was doing something after all. We love it. If anything, it'd be better if we do the caching here, but whatever. Potential of blah blah blah. What the heck happened there? Backward indexes, wheel indexes, forward indexes. Ghost PK is just, I'm building up that key for you. Next P, pull +1. If PKM caches, then just give up. So we want really the inversion for you to keep going. Keep going would be a remaining push. Go on, live your merry way. Potential, we already have next P there. Drop all these dupes. Okay, I'm like 9-2, so yeah, we did the same thing, we just did it up a little earlier. Which means now we can bring this down to when we actually have our results. So this is after wheel 1 pull, I just realized. Right? Yeah, this is after the pull of 1. So right here's when you do the pull, here's where you see your results. Max, min. These coins, I believe, are being calculated correctly. Backward indexes, go down if you're below. Go to the end, forward. You're just going forward another one. Middle, you stay where you are. Yeah, all these are correct. Interesting. Well, something got stopped up again. 24/8 to be 26/5. Those numbers look a little different now. Also, Wallaby looks a little weird. Yeah, 24/8, 26/5. Okay. Let's see. Yeah, I'm not seeing things show up. That's why. Come on, give me the cache. All these duplicates. I'm doing cache checking up here. Don't know what you're doing. Dang it. Okay, fine, we'll do another cache check. Put it back up here. It means my efficiency down there is not doing its thing, but whatever. Yeah, so cache K 23.7. Hold on, we had a different number there. 23.7 to be right. So before I put this in, we run a bit longer, which is sad, but we were running longer. We were hitting a better number. Okay, I guess that's not happening anymore. It's something obvious, right? Something so obvious that I probably need to redo it to see anything change. Maybe. Yeah, wheel indexes, I'm moving them forward always here, so I get them, I move them forward. I do the funness there. Do I need to move? Right, I'm only bringing... I think that's the problem. No. So if these are the wheel indexes, and they'll all move forward normally like this the next time they come through, then they are getting moved forward. My concern was that, okay, the normal's going forward, but the backwards or forwards aren't being pushed, but they are right here. And you know what, yeah, I just did all that here for the caching. Let's just drop that comment since it appears not to be doing its job. Okay, let's think about mutability. Maybe we're mutating some bad stuff. So we have the potential. Let's drop the PK, we're not using that. So this is an array of numbers. As soon as we get the array numbers, we reassign it to a map of it. So no bleed through there. Map all of these. Maxim about our coin counts. This is an array, we destructure it. No referenceability there. Then at the end, we push this up here. Okay, it might just be better as a recursive function. Because this ending state, it's got me worried it's not doing the thing. So let's try good old recursion. Which is basically this, but... where'd my cache go? There it went. Bring that cache back up. Still gonna have a cache, still gonna have most of the things. It's, just gonna be inverted and maybe a little bit more logical to follow. So, our parameters, that is wheel indexes. What's the next one we get? Pull. And we won't need the coins because that'll be our return values. We won't need to keep passing them forward. It's just what we have. Which means our key is the same. Instead of continuing, we would return cache key, which again, is a bit more logical. Let's do all of this. Did I not destructure all the things? Oh, well, these are new things. So, const, well, let's call it let. So we'll get to add to them when we keep going. So if pull not equal pulls, exact same logic, keep going. Otherwise, you just end with your results. So keep going is this. Okay, I'm just going back the old way because we're adding to these variables. It's a call to recur with backward indexes and pull +1. But what am I adding? Because this is giving me both min and max. That's tough. Okay, I might need to do caching a little differently. Or at least searching a little differently. I commented everything about the one thing I was looking to. There. Okay, let's think this through. We need a separate one for min and max, which means we need a separate call for min and max. Which means we'll need a separate cache. I mean, the cache didn't really get that big, so honestly, a second cache doesn't sound the worst. The min cache and then the max cache. It depends on what you're looking for. We'll call it goal. And sure, put the goal in there too. Well, now we can't programmatically pick a cache. Let's put the all in one variable. Now I can programmatically pick a cache. Yeah, I mean, I just made it part of the goal, so I can just leave it like that. Okay, hopefully I don't need to target that later, but move on now. I do feel like we're going to do double calculations for the purpose of looking for different things. But it's okay. Make that a goal. Do the same thing for the other two. I like it. And then no matter what your result is, we got to put your thing in the thing. Since I have it, well, I have to because I can't do all weird parsing of junk. So const result equals math goal, and then what we three got: backwards coins, and forward coins. Then I put that in the cache. Cache key equals result, and of course, old logical, return the result. Now, in theory, how do I start this off with the base call, which previously my base call was this. So something like this. I might just be able to return it, actually. So if I base call it with this, I just say, hey, my goal is to look for the minimum. Oh, come here, you. 2. 9, 2. That is correct, I believe, for one of them. Sure, and I'll just do the max. Hey, that is one of them. Let's do it. Okay, those two. Those are working. Oh, okay, we're working on the hard one too. Love it. Oh, that's all of them. Okay. Well, that's all the examples. So performance might be gone, but I figured out how to make it work. Let's drop some trash. Drop all of the trash. It was useful, not no more. Do I have any more logs? Drop the trash. I don't see any more logs. So where's my real input? Okay, I have a dot only here. Let's move that to there. Drop this. I am asking Quokka to do this. Expected 2 got 1. Right. What's the thing? 256. Did I put quest 2 on it? That's a number. Is that not the exact same number? Okay, it's not the same number. It looked identical. I was really sad for a moment. Boom. There we go. Woo. We got it. Woo. Okay. This is why they say recursion is pretty nice, because I could have done the same thing with the iterative stack, but mentally I just wasn't able to track it. Okay, so that was the solution. Let's walk on back through the challenge, figure out what the heck we were supposed to do. So, it's all about gambling, right? We're gambling. That's it. So, we're given these wheels, these faces of wheels, and each column is how many faces that wheel has. So, this wheel has 3 faces, so it's less of a wheel, more of a triangle. This wheel has 5, this wheel has 4. And it's a slot machine or some spinning wheel, multi-wheeled thing. And every time you pull the lever, your face in this column moves this number. So we'll start at the beginning one, but then you pull the lever, you move forward 1. This one moves forward 2, and the other one moves forward 3. And they retain that position, so you pull the lever and you move forward another 1. Another 2, and then another 3. And that just keeps on going until you stop pulling the darn lever. Now, how much you win depends on how many repeated characters there are. So for this row here, we have 3 repeated hyphens, so we earn 1 coin. For this row here, we would have 4 repeated hyphens, so we'd earn 4 coins. So you need at least 3 to get a single coin, and then every additional repetition of that character is another coin. They go through this example down here. They even explain that you could have a minimum 3 of multiple characters. So we have 3 of underscores, which gets us 3. Then we have 6 carrots, which gets us 6. 4. Gives us 4. It's math. There's math in there. Forgot the math. Part 1, do this 100 times. Give us the last face. So don't even get to do any coin calculating, which I failed for. I was like, we're calculating coins? Okay, let's do this. And I'll return how many coins you win after 100 runs. No, they don't want that. Part 2 is just go further. Just do it a lot more times. And this time you are counting the coins. But wait, that's not all. You are ignoring the middle character of the cat faces. So, like, these little characters, they completely get ignored now. They call this the muzzle. Don't know why. They just, threw a random change to the calculation before we even did any calculation in the middle here. But it's here, and we do it. Now, the trick about this being so much larger is that you can do some cycle detection to detect when you are in a cycle, and then fast forward until you reach the number of pulls you're supposed to hit. That's what I did there. Part 3. All kinds of different universes and stuff, where they basically introduce with every pull, or before every pull, you can decrement or increment the position of your wheel by 1. And that's an absolute 1, not 1 change of this. They explain it here, and I still can't for the life of me figure out what exactly this example is trying to tell us. But basically, they want you to do that, so simulate all those universes and return the smallest and maximum number of coins you can win based on sometimes going backwards, sometimes going forwards, and sometimes not changing at all. And there we have the code that I used to solve it. which is going to be great when we do some refactoring. So let's drop that one. Drop some of this other stuff we didn't use. Oh, this is my Windows bit here. Okay, I'm going to have to figure out how to keep this around. Okay, so we got all the unused stuff out of here, it appears. Hey, why did everything just turn red? Oh, I haven't put the number in. How much runtime we do have on this one? Whoops. There we go. Let's drop some comments here that are doing good stuff. Let's drop the only. Let things run. And yeah, they were cool about both examples, giving us basically iterative of like, hey, this is where it is at this point. So it made the code a lot easier to test. Oh, that part 2 notes is a big one, I just realized. Let's skip that one for now. We'll come back to it. Yeah, and part 2 real is stuck in a file, so I gotta get that too. Yeah, I think we're gonna stop Wallaby for this one. So let me get a test for notes and do some file shenanigans. There we go, we got our file system. Let's go get our real input. So that'll be cost input with file sync 2.txt UTF-8, don't worry about it. I'm gonna do some cleanup stuff. Yeah, I'm just gonna clean all of those up because that was gross. And theoretically, we can now expect solve quest 2 input to be for whatever it is. Oh, solve quest 2. I need to provide a second number. How far we're looking to go? Yeah, the future. Okay, yeah, let's get Jess back in the equation here. Part 2 notes, hit it. I mean, it was a big input. Took me what? I think less than a minute, though. Okay, it's still a chunky input, I suppose. There we go. npx feed test. Let's get a reload on this. Save my computer. Or kill my VS Code, whichever works. Okay, yeah, so it'll run, it fails, there we go, 127, which is the right number, there it is, yep. Where'd it go? Right in front of me, whoops. Okay, so I think we have everything back. Stop. One fail, 1289, expected number received, funny face. Yeah, that's on me. I'm supposed to put that in there instead of that. Boom. Okay, we have our initial code. I have a skip. Let's drop the skip. It's funny, the example almost takes long. I mean, actually, it's not funny. It makes complete sense. Add initial 16 solution. There we go. It's refactoring time. Oh, we can get rid of that bit. So I think parsing and all that does the real easy part. So let's do that. So function parse machine notes string. We want basically everything up here. Specifically, we want the wheels, and then what do we call these? So I just call them numbers, but we could do something better. Wheel turns, turns, sure. Where'd they go? Oh, numbers, there we go. I was thinking, like, what the heck do I need these for? I need that for that. Okay, so we have everything we need. Parse machine, we get wheels, we get turns. There we go, we do that. Let's see where we are now. Let's rename this from indexes positions. I like that better. Another rename to that variable. So yeah, I think we're doing good here because we actually want whatever's on the faces to be coming out. I am going to put the modulo over here because I like that better. I feel like I put it in the wrong place. I did put it in the wrong place. And we need positionals there. Okay, let's make sure all our ones still work. Oh, go back up. Love it. Okay, so we have our results, we have our positions. Go through 100 positions, get updated. Our results. We just take the positions and we put in whatever's on the faces, the good. This assignment, yeah, let's come back to it later. Const, what do we have? Wheels and turns. Turns, there we go. I'm liking positions with this. Index results. We have our old log there. Let's drop that. Previous positions. Yeah. Previous positions. Or position history. Position history. There we go. We have total coins. We have positions. The position is doing its job. Yep. Okay. And what do we have? Result coins. Which this can be put in a function at this point. Let's get this in a function. Count coins. There we go. Great function name. Count coins. Where's... Oh, because you're in here, huh? Let's take you out of here. Let's share the love. We just passed you a result, which is... Do you do the mapping? You do the mapping in there. Okay, I'm just going to pass you the result. Which means we can just shove you... Well, we do got to make you a cost, because you're used in 2 places. Yep, so we have the result. We immediately put the result in there, so let's immediately put the result in there. We add it to both things, and we keep track of where we are. Otherwise, keep the increment. We have the next S. We keep going until you hit the end. Cycle total. Well, cycle coins. Next X. Then we have remaining, and we use that to do all that. Let's put the end where that is. Okay, so let's make sure this is all above board. Cycle coin, keep adding that. So we add to the total, add to the thing, add to the next increment. This is a freaking for loop. Let's make it a for loop. Before I break it though, let's make sure this is all working. We don't have a small part too. 4 seconds. Jeez. And can't read the file. Okay, well you can read the file when you want to. I think I'll go terminal based for now. I forget that's gonna. No, we'll see about that. Okay, yeah, it's gonna do the whole thing. I can chuck a dot only here. Save myself some time. Nice. Okay, we'll live off of that. It's gonna be a little input there. Okay, let's trim this down. So we have remaining, which is there. We need that for 2 variables. Yeah, for loop is what I was saying. For let next s equals s plus increment. Next s less than pulls. Next s plus equal increment. Yeah, that's my for loop. It's right here. Oh, it would help if I had some curlies on this. Boom. Okay. Well, actually, that doesn't tell me if it passed. A little bit more input than that. Okay, it passed. Okay, so yeah, this is what I want to do. It's basically a for loop. Increment is our thing that technically goes in there, but not really. We're just overloading this for loop if we want to, which I do. I very much do. Cycle coins, you know, like, okay, I'm not going to overload that for loop anymore. It's doing a lot. I'm seeing a while loop get back in here, though. Oh, come on. So I can do next s plus equal increment less than pulls. We'll still need to define it out here, which at that point I'm using this as a derivative to not go over the limit. I can just use freaking s. And I really don't need this while loop. I can just figure out how many whole times there are and do math. Do I go for good or do I go for great? I'll go for good first, and I'll figure out how to be great. So we do need next s equals. I guess it starts off as s. There we go. Let's save that. Look at it. Beautiful. Okay, so let's count the number of increments now. Basically the number of times we can add to increment until we hit the thing. So it's the difference and then how many increments goes into the difference. Cos diff equals pulls minus s cos increments into diff, which is diff. Okay, I need a sandbox for this. Let's see, our increments are 25. And you want to get to 80. So, our increments are 25. S equals 0. S equals 0. Increment equals 25. Diff, well, pulls equals 80. 80 diff equals pulls minus s. Diff, you need to get 80 ahead, right? Sure. Now it's feels like diff modulo increment is wrong. Yeah, that's leftover. I want to do something else. Yeah, like this. There we go. It's that many. So it's math 4. Diff divide by increment. How many times we're going forward. It's basically that many times. So I can do that with math now. That I can just say S equals plus equal increment into diff times increment. There we go. Same thing for total is cycle coins increment into diff times cycle coins. There we go. That feels like what I'm trying to do with the math here. We'll find out. And then the partial gets done here. Look how fast math is. Crazy, I know. Who would have thought? So it's cycle increment. We'll call this remaining, even though we got another one. So yeah, we'll just recalculate remaining at the bottom here. Make you a let cycle count. There we go. It's how many cycles we're gonna go. And then remaining is pulls minus S again. Add to the total, add to the S. I love it. See if we can We're just gonna do that once for math. Excuse me. I think this is part 2, doing a lot better. I think there's a little bit more polish to be done here. We have an if else. We can just continue. Drop that, drop that. I wonder if we could offload this work to the main loop. I don't think we can. Yeah, it's 3 lines too. It's not really the end of the world. It still works, right? Boom, still works. Hey, let's scroll. Boom, still works. We have total, we have coins, position history. We need all of these things, unfortunately, to go. Let's rename this to P for pull. Same up there. Where to go? I love it. Let's actually make this one base, because that's how the lore goes, right? There we go. I like that a little better. Where'd it go? There it went. I don't believe I do any math based off of this until part 3. Whoop. Nope. No, I do. Apparently I did that. Whoops. Oh yeah, I did. I literally do math on it. Right here. Well, I just incremented by 1 and I did the whole thing, right? So that shouldn't be a problem. It obviously is. Don't need to check a -1 in here. Oh hey, that's an infinite loop. Let's stop that. You know what? Maybe I don't need it to be is that 1 based? Perfectly fine if going 0 based. Please stop killing my computer. Okay, we're good there. So yeah, coins, position history. Let's make the const. Yeah. We need that. We need that. Just for cycle protection purposes. Yeah, I think that's pretty good for part 3. Part 2, rather. I didn't get to part 3. Let's move our helper a little higher for everyone else to be cool with. Cool. Yeah, I think this is honestly perfect. We could reduce it a little bit. I'm good with it. We're using counts. We're returning direct coins. Yeah, I love it. Okay, quest 3. Let's get that parsing going. Boom. And now I know we got turns here. Okay, yeah, and our recursion was the way. Could have done it with that stack while loop, but my brain just wasn't braining on it. So I don't need the goal as part of the cache. Well, that's the great thing about testing. We can just move our dot only to the next one, or maybe we don't need the only. What are our timings again? And part 2 adds a whole second to our run. Let's keep it on everything. So yeah, let's see if we need the goal in our key. I think we do, because our changes are based off of the goal. Yeah, we did need that. Hey, it's a great thing about testing. Refactoring is so easy. And now our cache is a string to number, so I love that. Can we reduce the impact of this at all? We got a string in there. We got 4 numbers in there. No, we can't really do number math here. It wouldn't work. Okay, then we have this, where we're moving our indexes around. We're getting our coins. We're doing the thing to add more coins if there are more coins to add. So my counting of coins, how do I do it previously? Again, with positions. Okay, so I am using an intermediate data structure for this. Let's think about it later, though. This can be done a little better. Let's try and go for that. I don't do this enough to have it memorized, but I know we can use the length of the thing to do it. Basically just add the length and let a modulo do its normal thing. So let's figure out... Yeah, so normal going forward is this. So let's just go straight to that. Well, that's not normal, that's term-based. Normal going forward is this. If I just add the whole length, I might need to do a -1. Let's find out. Yeah, I don't like that. -1. Well, where'd my thing go? I can't tell. Oh, okay, that's working. Was it working before? No. Yeah, well, -1 is the modulo backwards based on length of thing trick. Just was not confident in the moment to go for it. Okay, so we have wheel indexes, forward index. Yeah, I don't like the word index, as I said. I said I want positions, so... Positions... Backward positions, forward positions. There we go. Which actually, backward positions, I was thinking of like, hey, they're just the positions before I calculate the new positions. No, because they're -1, not minus turns. Yeah, this map is going to get undone. So a little function that just says go forward. Let's see, with backwards, forwards, recur, full, goal, all that stuff. Get the result, put the result, return the result. Well, we can save this easier. A little janky, but it works perfectly fine. And yeah, we don't need this anymore. We can just put that straight in there. Yeah. I like it. I like it. Okay, coin counting, position incrementing. Let's go to position incrementing. So let's say, what do we want to do? Function turn wheel positions, turns. It's basically, I just want to do this not with a map. I mean, I love my map and I love my assignment. I could just do this with a for loop. Let w equals 0, w less than, what are these positions, dot length, w plus plus, positions, w equals, hey, I need the wheels to know, okay, that's a lot of variables in here, equals positions w plus turns w modulo wheels w dot length. It's a little grosser than I wanted this to be. Yeah, it works. I mean, it'll feel a little better with TypeScript, I guess. Do I have types on these returns? No, it's just an any. Hey, let's fix that. There we go. Now wheels is string. Love it. What are turns? Okay, at least those came across. Let's, while I'm here, you know. And yeah, let's get the relevance close, the extras out. There we go. Yeah, I think this will be cool. I don't know. I like it better, so I'm doing it. There we go. I like it. Here we go again. Whoa. There we go. Might be a way to reduce the variable here. I need to know how many faces are on the wheel. Kind of need that information. Yeah, there's no trimming that down. Boom, still working. Okay. Now, turning wheel positions, turns. These are all, of course, inline or in-memory modifications. I need these positions to pass forward to them, so there would be no point in doing it in line, like right here or something. Like, there's no way to reduce this memory because I need it to pass to the next thing. No, there's no way to combo this call. Yeah, all this WI, it's a little painful. WI and I, we can do more for readability here. Okay, let's try and go for this. So these are really positions, right? Position, and then W is the index of the wheel, which, if anything, is WI. Yeah, I like that better. Positions didn't get typed. Oh, yeah, I didn't type them. Come on, number. And then goal, bin or max. Yep, okay, things getting a little better. Record of string into numbers. Loving it. It's all still working. There we go. Okay, backward positions, forward positions, normal positions. Okay, I think we are nearly there. I just want to reduce this counting overhead. So I need to turn them into the faces, and then the faces do the counting. Where else do I do counting? I also take the positions and turn them into faces. So, do you think we need this? I don't think, because counting has one responsibility only, count. I just think there can be a function to do this. So let me see, function positions to faces. So it'll be positions number, and then wheels string, I think it's literally this code right here. There it is. I love it. I believe wheels. Let's rename all these to wheel faces, because that's what's in there. It's the faces of the wheels. Positions to faces. Now we can use this. Wheel faces. Boom. And nothing should be broken. Loving it. Let's do it in all the places. Then I can make a wrapper function, which I'm just going to do right now. Where'd that little helper go? Right here. Right here. Function count. Position coins, which is positions number. And then it literally does this. Oh, come here, you. There we go. Let's rename this one up. Position to wheel faces, and now we pass this down. Boom. And then you can't use coins because that one's already used, but we got this so much more simplified. And for this, we just need to pass the correct positions, which and the wheel faces. Boom. Loving that. I feel like this triplication can be addressed, but I might. So tempted, but I won't. It's fine as is. Doesn't need to go further optimized. That would make it unreadable. People like reading code, so let's make sure the code can be read. Okay, with that refactoring, let's walk through the solution. So, solve quest 1. All of them start with parsing out the machine. So what we start with is we split it up into first and last by the blank new line, which is right here. So first is all of this, last is all of this. Then we turn the turns into an array of numbers, splitting on the commas and turning everything in between into a number. Then we calculate, well, we make an array to store how many wheel faces we have. So this is just an array of this length. So it's an array of 3 arrays. All those are empty though. Then we calculate the index starting position of each face. So it's a 0 for like, hey, this is where this face starts. Then it's 4 for where this face starts. And it's 8 for where this face starts. It's a little bit of math, but it's basically the width plus the offset. It works out beautifully. If there were 2 spaces, it'd be +1 or some other thing, but this is the math to get the indexes of each face. We go through each line. We have the wheel index and then the actual face itself. So we're using these face indexes here to get our indexes here. We get our face by slicing from the starting character to the ending character, which is the starting character plus 3. We trim it because it could be empty space. So we trim it, and if it's not empty space, we say, hey, the current wheel that I'm on, let's add a new face, which is this, which, boom, optimization. If the old walrus operator here in Python, I could do some janky stuff, but we ain't got no walruses in TypeScript. And yeah, that generates the wheel faces and the turns. Then for part 1, since we're just doing 100 polls and we're saying where we end up, we create our results, which is where we're at. We poll 100 times. I just realized we could do this better. Let faces, which, I mean, we could just go straight up positions. Sorry. That's why you always walk it through, because there's always some extra optimization left on the table. Boom. Turns out we didn't need to do all the results stuff. We just needed to keep track of positions. So, what this actually does is it keeps and sets where our positions in the wheel for each face is. So everyone starts at 0. As we pull it, we keep turning the wheel positions, which I'll go into. And at the end, we map those positions to what faces they have, and then we return it. Which I just wrote a cool function for, position to wheel faces. So let's do that. Again, apologies for the late time optimization, but that's another optimization there. So let's start with the turn wheel positions. What it does is it goes through the wheels and the turns and the wheel faces all in sequence. So these are arrays of all equal sizes. So we're effectively iterating through all 3 of them. Our main target is to change positions. So we're going through positions, which I'm just going to change that back to P for positions. And we're saying, hey, the Pth position, you're going to be U plus however many turns is for your thing, modulo over wheel faces the length. So this isn't new, but it basically says, hey, we're just going to keep adding 1 to you until you hit basically the length, which is 3, which would be here. At which point 3 modulo 3 puts you back at 0. So it keeps you from going outside the bounds of this array. That's what turn wheel position does, a little helper function. Then we have, once we go through all 100 pulls, we can have position to wheel faces, which takes those positions and maps them to the wheel faces for their wheel that they're representing. Very, I won't say complicated, but keeping track of multiple pieces of state that are all tightly coupled. Could have been done better, honestly, but we're here now. And that's quest 1. Quest 2 is where we gotta do the cycle detection and the fast forwarding. So, do parsing, keep positions, and we just keep pulling. But now the number of times we pull is variable. And we generate a key based on our positions. So that's the thing that's going to allow us to detect our cycle. If we don't see it, then you're normal. We count how many coins there are. We add it to this array, which we need to. Then we add it to our total, which we want to. Like, this is what we care about, but we got to do the boring stuff here. I wonder if I can just calculate total at this point. Yeah, let's just do total calculation here. So this is, again, while you walk through it, you get to see some things you didn't see before. Total equals coins reduced, A, B. Basically, I'm reducing the complication a little bit by just inlining this final bit of code like that, and then we can just straight up return total. No, we can't do that? I thought I could do that. Oh, right. If you never hit a cycle, then you never do this thing. Hey, let's still want to be bad. Let's be bad. I think that's for the low cases that we don't care about. There we go. Okay. Thankfully, I haven't walked through it yet, so I don't have to explain what I did too badly, but we start with just tracking the coins and when we've been at certain positions. This is helpful for cycle detection. When we don't detect a cycle, we just keep a pile of coins and we just keep adding to it and adding to it. But then we do detect a cycle. And I'm like, okay, we detected a cycle. The game is over. This is our last iteration of the loop. So we calculate our total up to that point, and then we see how many coins are gained in the cycle, which is basically going from the cycle index to the current where we currently are. We add that up again. We figure out how many, like how much, how long the cycle is, right? If it's a cycle length of 10, a length of 5, whatever it is. Then we figure out how many pulls we have remaining, and then how many cycles we can go to not over pull. I did the math before, but this is basically how many we can do mathematically. We figure out that math and we're like, okay, let's just fast forward. We added that many coins times that many coins, and we increment our position times that many cycles. Then we have some left over. This could be 0, but it's usually not. We're like, okay, we have a few that we kind of got to do manually. We do know we are in a cycle, though. So we don't need to go straight up and do it actually manually. We just need to do a partial cycle. So the partial cycle is basically just saying, hey, this is what's remaining, and letting our slice be the partial. So if it's like 100 length cycle, you eventually hit it. It's like, okay, well, you need to go 80 because going 100 will put us 20 over. So this math does that. We add our remaining to our pull, which we don't need to do at all because we're never coming back to it anymore. And then we can just straight up return. And let's not return. Finally, we have for the poor schmucks who never hit a cycle, right here, this case here. And that is everything for part 2, of course. Part 3. This is all the recursion and all the fanciness and all the scary stuff. So, as with recursion, we kind of start with our initial. We have 2 of them because we're looking for the minimum and the maximum. So, I think there is some caching that doesn't happen here, but it's fast enough. Half a second, we don't care about any more caching. So first we start off our positions and our pull count, and then what we're looking for, the min or the max. So that's our first call. Positions, the number of our pull, and what we're looking for. We turn all that into a key. If we've seen it before, we return it. If we don't, we'll eventually make it. We turn the wheel faces, the wheels 1, and then we calculate the positions that are pulling the lever to go back 1, and then pushing the lever to go forward 1. It's 1 face, not 1 turn, so we can't really use this. So we use the trick for moduloing negative decrements, which is just going all the way around with the length. Then we just add 1 modulo around that. Then we count what our coins are in all 3 of these positions. Can't really get across. Can't really get around this. If we're not at the end, we add whatever the next recursion generates to our current count. This is what we weren't really doing with the iterative approach that we could have, but it was getting very difficult to follow because logistically, this is what happens logically. And then no matter what, so if you did have more to grab, great, you grabbed more pulls. If you didn't, you're good. We figure out the min or the max, whatever we're looking for. We put it in our cache for later usages, and we return it both to serve other things that are calling this and to serve our final function, which is the base. Well, not the base, the initial call. And that is everything. As always, it has been a pleasure. Bit of a toughy one. All these later day ones are starting to get into that habit, which is not surprising in the least. I meant to say slightest, but words. But yeah, it's all still passing as we can see. Just is really confused about file paths, but I'll tackle that some other time. But yeah, until next time.